All right, welcome back to Mr. P Helps with Algebra. This is Unit 2, Topic 2, Lesson 7, which is about finding real-world problems, solving real-world problems with arithmetic and geometric sequences. So warm-up is just that. So this, you notice that it's getting bigger pretty fast, which means in this case it's most likely going to be geometric sequences, because geometric sequences either increase or decrease very rapidly, much more rapidly than arithmetic sequences, because they're either adding a positive or adding a negative, which means they don't increase very, very quickly. They pretty much stay at a constant rate of adding. So in this case, we have multiplied by -5. So it is geometric sequence. The next number would be, what is that, 5? That would be positive 2500. Then multiply that by -5 again, and that would give you the next term. I'm not going to write it in here because I'm sure you can hear me. I'm just going to tell you what the answers are. So the next one is +2, +3, +4. So that is neither. That's not arithmetic sequence because it is not adding the same number each time. So this is what we call, this is a sequence of numbers that are created from a quadratic equation because it has what we call a second difference. So these numbers that it's adding by, so the differences are increasing at a constant rate. So we would say that's a second difference, not the first difference. The first differences aren't the same, but the second differences would all be +1. So that's quadratic. That's neither. This one is also neither. I know it looks like, once again, it looks like an arithmetic sequence. It's not. It's not. I believe is adding, let's see, 16. So this is adding -16, and then it goes to -12, and then it goes to -9. So there really is no pattern there. So that's another neither. It's not quadratic because 16, 12, 9 doesn't really have a second difference. Now, I guess you could say it has a third difference, and we can get more into that later, but I'm not going to right now. So this is an arithmetic sequence. That was geometric. This one is arithmetic because it's adding -3/4, which is 0.75. It's decreasing by 0.75. And if you continue that pattern, it's going to go to -1.5 and then -2 1/4, 2 and 0.25. All right, so like I explained before, piggies and pools. This lesson is about just that. Some are about a piggy bank and saving money, and some are about a pool, draining a pool, and filling a pool. So we've got arithmetic and geometric sequences. This happens to be arithmetic sequences because it is, she's given her sister 5 pennies and 3 pennies per day. So if I was going to write that with a model, that would be 5 pennies to begin with, plus 3 pennies per day. Per means multiply, x is the amount of days. Y would be the total amount of pennies. So if I want to solve that, all I'd have to do is put 10 in for x and solve. 3 times 10 is 30, plus 5 makes 35 pennies. All right, and how many days will it take for it to have at least $1.50? So I would set that up by saying there's 150 pennies in $1.50 equals 5 plus 3x, and now I can solve for x. Because as long as you know either x or y's value, you can always solve for the other. So in the first question, we were trying to solve for y, and in this question, we're trying to solve for x. So I would subtract 5 from both sides. It gives me 145. Divided by 3, I believe, gives you 48 1/3. So will she have enough money after 48 days? No, she will not. It will take 49 days to have enough money in a piggy bank. Because that is a discrete question. Discrete meaning it's not going to continuously have pennies in the piggy bank. Because pennies, you drop them in one at a time. Either you have a penny or you don't have a penny. There's no in between. You're not going to have fractions of pennies building themselves inside the piggy bank. All right, so this question is about water, and we start off with 1,500 gallons. That's how much it takes to fill the pool. And here's the rate. It's increasing. The hose is increasing at 2 gallons per 5 minutes. And after 5 gallons, she decided that she doesn't want to watch I don't blame her. She doesn't want to watch the hose anymore. So she stops. So y equals, so when she stops watching, there's already 5 gallons in the pool, plus it's increasing at 2 gallons per 5 minutes. That's the rate, times x. X would be the amount of minutes that she's watching, and I'm going to let y equal the total amount of gallons in the pool. All right, so this one is also arithmetic, and this one is increasing because the pool is getting filled with water. So 50, if I put 50 in for x and solve, because x is the amount of minutes, 50 times 2/5 plus 5, I believe that's 25 gallons. Because 2/5 of 50 is 20. 50 times 2 is 100. 100 divided by 5 is 20. That's how I'm doing it. Or you can use a calculator. How many minutes will it take to fill the pool? All right, so this one, I'm going to put 1,500 in for the pool. Now, both of these questions are a little bit deemed for interpretation because, I mean, are you think of like how many minutes it take to fill the pool after the 5 gallons or before the 5 gallons? I'm going to solve it as in after the 5 gallons, which I know in class I might have done the opposite. So 1,500 is the total, equals 5 plus 2/5 x. Subtract 5 from both sides, and then multiply by 5 over 2, which is the reciprocal of this. That's how I would solve that. So that gives me 1450 after I do subtraction property of equality. Then I do multiplication property of equality by multiplying by the reciprocal of the 2/5. And that gives me, I believe, if I'm not mistaken, like 3,700, give or take. It's slightly less than that. I don't have a calculator on me. But you're going to get in the ballpark of 3,750, which I think it actually ends up being like 37.5 or something like that once you solved it. Okay? But the main point is that we understand what kind of equation it is, and we know how to solve it. So this one, now we're getting into geometric sequences. So her older sister is a little more sophisticated. She doesn't put money into a piggy bank. She instead puts her money into a savings account. So that savings account is going to be growing exponentially, 3% interest each month. $50 is how much money she's going to put in there. So it's always starting point, that's how much money she started with in her account, times the rate. Now, if it's putting money into and getting interest, that means it's increasing at a geometric rate. And this question is probably the most important to help you understand this. What would you multiply a number by to keep it the same? So what would this rate have to be if it was never changing? What would be 1? Because anything times 1 is itself. If you multiply a number by something greater than 1, it's going to increase. If you multiply a number by a number that's less than 1, it's going to decrease, meaning a fraction, not anything less than 0. All right, but if times a negative would make a decrease, but well, it'll go back and forth. So anything less than 1, decreasing. More than 1 is increasing. So in this case, I'm going to multiply by 3% more than 1. Well, you should have learned last year that 3% is the same as 0.03. And if you add that to 1, it becomes 1.03. If it was 7%, it would have been 1.07, and so forth, to the x power. Now, I don't have a graphic calculator on me, which is one of my flaws here. How much money will I have in the account after 10 months? I really need a graphic calculator. I can't just use my phone because the phone doesn't have exponents on it. So what I would do is I would put 10 in for x and solve. So using your graphic calculator, do 1.03 to the 10th power, and then multiply that by 50. Whatever that gives you, that's your answer. Sorry, I don't have the answer right now. How many months will it take to have at least $100? Now you want to put $100 for y and solve. Now, a good idea to do to solve this question would be to put this function in the y sub 1 in your calculator. So you press that y equals button, you put this equation in, and then you go to the table, and then you can literally scroll down the table and find when it became $100. That, I think, would be the easiest way of solving that problem. All right, so now another question. At the end of the summer, I decided to drain the swimming pool. So now it's decreasing because we're draining the swimming pool. It's still a geometric sequence because we're multiplying at a rate. Anytime you're dealing with a rate, a percentage of means multiply. And if it's multiplication, then you know it's a geometric sequence. And if it's geometric sequence, then you know you're dealing with an exponential function. Yeah, I know it's a lot to remember, but that's why I keep reminding you of all the same stuff because you will get it. Y equals, justify your reason with mathematical models. So there was, how much was in the pool to begin with? Oh, I forgot. I'm going to need to scroll back to that last question. So it was 1,500 gallons to begin with. And we're multiplying by a rate of 3% decrease. Now, this is where it gets tricky. Remember, I told you a decrease means it's less than 1. Well, 3% less than 1, if I take away 3% from 1, I get 97 hundredths. You see what I did there? I subtracted. 1 minus this is this. Because anytime it's a decrease, it's going to be less than 1. It's going to be subtracted, basically. It's going to be taken away. So then it's to the x power. So now you've got the equation you can use to solve both these questions. Put 50 in for x and solve, just like you did on the last question. Put 1,000 in for this. And then once again, Good strategy for this, put the equation in the calculator, let it do the work for you, and look at the table to find when was it 1,000 gallons. All right, getting to the homework now. Discrete versus continuous. This is more of a review than anything else. Discrete meaning that only certain numbers will work. So we're talking about the piggy bank. When you drop pennies into the piggy bank, you can't drop in half a penny, or you can't have a third of a penny, so that would be discrete, because a half doesn't make sense. Whereas continuous would be always growing. The first one, number 5, is continuous, because hair is always growing. So can you figure out how far it's grown after 3 days, for instance? Yes, it's grown something. Now, it'll be very, 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 very small amounts, but it is continuously growing. For every ton of paper recycled, 17 trees are saved. Well, this would be discrete. And the reason why this one is discrete is because you can't save half a tree. Either you cut the tree down or you leave the tree as is. So if you recycle 1/100th of a ton, you're not going to save any trees because you still got to cut one tree down to make that paper. Approximately 3.24 billion gallons of water flow from Niagara Falls daily. So after a half a minute, have some flown over? Yes. The water in Niagara Falls is continuously always flowing over, so that's continuous. The average person laughs 15 times per day. I don't think you can laugh a half a time. I think it's either a laugh or not a laugh, so that would be discrete. The city of Buenos Aires adds 6,000 tons of trash to its landfills every day. Can you have half a ton of trash? Yes, you can. That would be continuous. There's always adding up trash. During the Great Depression, stock market prices fell 75%. The stock market prices fell. Do the stocks always have a price? Yes, they do. So I would consider that continuous because they always have a price, even after a half a day, half a minute, half an hour. They always have a price. That is continuously changing. All right. So, 12 minutes. Thank you for watching the show. If I helped you out, please give it a like and definitely follow the channel if you haven't done so already. All right, thanks for watching. Have a great day.